and the column will be loaded by the bolts under the bearing. So the forces will then be transferred to the column, which will take it to the foundation. So the load path is as follows. It goes from beam to the bolts which are bolted to the beam web, and from the bolts it goes to the connection element. For in this case it's a single angle, and from the connecting element it gets transferred to the bolts that are bolted to the column, and then the bolts that are bolted to the column will transfer the forces to the column itself, which will transfer the force to the foundation. So this is a typical load path for the connections. It stays same for both the shear and the moment connection. So now this will help you on what portions are to be designed. So as the forces will be going from the structural member to the bolts, we need to ensure that the bolts are capable to resist the forces that are coming from the structural member. And then the bolts will again in turn transfer the force to the connecting element. So the design of connecting element has to be done so that it can resist all the forces without deformation. And the connecting element will in turn transfer the forces to the bolt that are bolted to the column. So the sufficiency of those bolts has to be checked. And then those bolts will be transferring the forces to the column itself. So we need to ensure that the bolts, while transferring the forces, do not damage the column flanges. Understanding the load path helps us clear that which part needs to be designed. That wraps up the shear and the moment connection portion of the webinar. Now we'll be taking a look at another sort of connection, the pinned and the fixed base plate connection. This connection has been classified in the compression connection in the classification that we saw in the previous slides. So let us first have a little overview about what are base plates. So steel columns are generally supported on concrete blocks, which are part of the foundation system. But in case the loads that are oncoming from the columns are very large, so that the bearing capacity of the concrete will be exceeded and the concrete will crack or fail due to certain conditions, then to distribute the oncoming force to a larger area, we provide a steel base at the end of the column. This steel base will project outside the column flanges, and this will increase the area over which the load will be transferred. So there will not be any concentrated load on the concrete, but it will distribute it over a larger area. This steel base at the end of the columns is called as a base plate. There are two types of column base plates. One is the pinned base plate and another is the fixed base plate. The pinned base plate resists only three types of forces. It resists compression force, it resists the shear force, and it resists the uplift. Uplift is nothing but tension forces. And the fixed base plate, apart from resisting the three forces which we enumerated in the pinned base plate, it also resists the moments. The base plates are connected to the foundation with the anchor bolts. And please note that the anchor bolts are different than the connection bolts which we saw in the shear and the moment connection. The connection bolts for the shear and moment connection would be 8.8 grade, while the anchor bolts which are generally used are of 4.6 grade. The IS code which will give you more information about the anchor bolts is IS 5624. So like we saw for the shear and moment connection, we will begin with the two types of columns here. One column has a simple support at the end, and the other column has a fixed support at the end. So to understand the behavior, we'll apply a load at the simply supported column in a lateral direction. The deflection of this column would be as shown in red here. Now, when a similar load is applied to the fixed column, the deflection would be as follows. Again, note that in line with the shear and moment connections which we observed before, there is joint rotation at the simply supported column, and there is no joint rotation at the fixed column. So the deflected shape starts becoming prominent at a certain distance away from the connection joint. Now, as we have seen the behavior of the simple supported column and the fixed column, let us see a typical behavior of a column base when it will be subjected to a moment. Here on screen, you can find a column which is subjected to a moment, and we can see that it tends to rotate, right? It tends to rotate and it loses contact at one end of the foundation, and it applies compression forces at the other end of the foundation. Now, what do we do? This is actually an undesirable behavior of the column and a base plate. We need to prevent this rotation. So we need to provide some restraint which anchors the base plate to the footing. You can see that we have two lines here. Providing anchor bolts at these two locations will ensure that no loss of contact occurs between the base plate and the foundation, and this will give the base plate a huge moment resistance capacity by the virtue of the distance between the anchor bolts. So when we put anchor bolts to prevent this kind of behavior, the base plate will look like this. You can see the image on the screen here. You can see that at the two lines which we saw in the previous slide, we have the bolts here. So this actually has the total number of 4 bolts. 3 are visible on screen. 1 is hidden behind the column here. So this is what a fixed base plate looks like. The salient feature of the fixed base plate is that the location of the anchor bolt has to be outside the column flanges. This ensures that there is a sufficient distance available between the two bolts, which increases the lever arm between the two bolts, which increases the moment resistance capacity of the same. Let us look at the characteristics of a fixed base plate. As we discussed before, the fixed base plates will always have anchor bolts which are located outside of the column flanges. And the fixed base plate would be transmitting the compression, shear force, the tension force, and moments to the foundation. And this base plate, when adopted in the structural system, will result in a heavier foundation, but in a lighter steel superstructure. So these are the important features of the fixed base plate. And one of the factors which can affect the selection of a base plate is the last point, that the foundation design can be on the heavier side because of the fixed base plate, but it can result in a lighter steel superstructure. As we have covered the fixed base plate, now let us take a look at the pinned base plate. But as we saw here on this slide, the pin base plate, this is the problem that is going to be there for the fixed base plate, the application of moment. A pin base plate will not be subjected to any sort of movement, so it will not be subjected to this loss of contact with the foundation. So as it is not going to be subjected to this, we don't require anchor bolts at such extreme distances from each other. Right, we don't want any moment resistance in the pinned base plate, so we don't want to unnecessarily increase the size of the base plates. So we need anchor bolts to anchor it to the foundation, but we don't need them at such extreme distances. So how will a pinned base plate be detailed? Let us see. Here on screen, you see a typical detail for a pinned base plate. Please observe the location of the anchor bolts with respect to the fixed base plate. The anchor bolts are located well within the flanges. This is the way we can identify a pinned base plate anywhere. If we go at sites or anywhere, we see the anchor bolt locations and we can make a logical judgment that this connection would be a pin type base plate. Let us take a look at the features of a pin base plate. As we discussed, this pin base plates will have anchor bolts located within the flanges of the column, and the forces which will be transferred by the pinned base plate to the foundations are compression force, the shear force, and the tension force. And as we discussed for the fixed base plate, adopting pinned base plate in a structural system will result in the foundation being lighter, but the design of the steel superstructure will be on the heavier side. So these two are the important differences which we need to be aware of. For a fixed base plate, the foundation will be heavier, but the steel superstructure will be light. For a pinned base plate, we'll have a lighter foundation, but the steel superstructure would be on the heavier side. So let us now, we now have a basic understanding of the pinned base plate and the fixed base plate. Let us see the load transfer, how the load path is from the base plate to the foundation. Here on screen, you can see the image where an axial compression force and a moment is applied, and 4 anchor bolts are used to anchor it to the foundation. So when resisting the axial compression, there will be no role of the anchor bolts. The axial compression will directly be transferred from column to the base plate, and the base plate will distribute it over a large area of foundation. So for axial force, no participation of anchor bolts. When it comes to the shear force and tension, the shear force and tension get transferred through the anchor bolts, but how does it reach the anchor bolt? The columns are basically welded to the base plates. So from the base plate, the shear force and tension will get transferred via the welds to the base plate, and the base plate will transfer it to the anchor bolts, and the forces will be transferred to the foundation via the anchor bolts itself. This difference needs to be known here, that for axial compression, there is no role of anchor bolt played in the load path. For shear force and tension, the anchor bolt comes into picture. Now, when we come to moment, moment generates two sorts of forces in a base plate, that is the tension and the compression. If we can see in the image, the where the cursor is right now, there is an arrow pointing downwards here. So when the moment is applied in a clockwise direction, it will generate a tension in the anchor bolt line on the left, and it will be generating compression in the anchor bolt line along the right. The compression will not be in the anchor bolt, it will be on the surrounding portion of the anchor bolt. We can see the stress distribution in the footing here. So when it comes to moment, the anchor bolt, the two anchor bolts in a four anchor bolt base plate will come into picture for resisting just the tension forces, while the compression will be resisted by the bearing on the concrete. So now that we are done with the load path, we'll summarize the concept of the pinned and the fixed base plates. So the features of the pinned base plate are: it will have anchor bolts located within the column flanges. It will transmit compression, shear, and tension to the foundations. And this base plate will result in always a lighter foundation and a heavier steel superstructure. Coming to the fixed base plate. The fixed base plate will always have anchor bolts located outside of the column flanges. It will transfer compression, shear, tension, and moment, these four types of forces, to the foundation. And this base plate will result always in a heavier foundation and a lighter steel superstructure. Now, coming to the career opportunities here. Connection design is always an integral part of the steel structure. So wherever an industrial steel structure is to be executed, connection design will always be an integral part of it. Therefore, it offers us connection design experts opportunities in many industries, beginning with the oil and gas industry. We have giants like Linde, L&T, Bechtel, Fluor Daniel, that all work for preparing the refineries for many clients like BPCL, HPCL, and all of them. And all the refineries have steel structures within them. So there is a huge scope within the oil and gas industry. For power industry also, we have giants like Macon, L&T, Adani, Tata Power, Torrent. For the pre-engineered buildings, it's an upcoming field. So all the design companies for PEB require connection design experts. Then we have reputed structural consultants like Arup and Atkins. They design steel structures, and as they are designing, they will always have a requirement of the connection design experts. And one of the next field where there is an opportunity are the fabrication companies. We have huge fabricators like William Hare and L&T here in India. So these fabricators, why do they need connection design experts? Is that because one of the manner in which the projects gets offloaded to a fabrication company is that along with fabrication, they will be performing the engineering design of connection itself also. So they'll be given with the forces from the design company, and they will be have to design connections at their end. So this requires connection design experts even at fabrication yards. Then we have the heavy lift and transport companies. Mammoth is one of the giants worldwide for this. And this field, and the number listed 6, it is largely being developed right now because of the advent of modularization in the steel structure discipline. So the future of the industrial structure is always the modularization. And what is modularization? It can be summed up in few lines that a structure would be assembled in modules away from the site at a workshop, and then these pieces of the structure would be transported as in the form of modules to the site, and they will be stacked over one another and just connected together. This saves a lot of time at the site, and it can result in early completion of the jobs and early startups of the various plants. So it's a very promising field. But modularization adds design challenges within the design office. For the engineers that design the structures, it's an additional work for them because it needs further analysis like the lifting analysis, road transport, and barge analysis, and a module assembled in a yard will have to be lifted and put on a truck and then transported. So this different sorts of force of the forces that a structure will be subjected to, the same forces will be subjected to the connections. So the connection is the same, but it needs to satisfy all the different loading conditions that will be encountered during the process the module reaches the site. So the connection design expert's role is to ensure that the connections are always safe under all these design conditions. So companies involved in modular structures have a huge requirement of connection design experts. So with all these plethora of opportunities available to us, the professionals with the knowledge in connection design are always going to be a highly sought after commodity in the job market. This is all from my end.